Welcome to Lesson 4, Solving Equations. In the previous lesson, we learned how to read and write equations, but in this lesson, we're going to learn about the different methods that we can use in order to solve the equations. So, when we solve an equation, we're finding the value of the variable that makes the equation true. So, considering the following equation right here, we have x, an unknown number, or our variable, plus 3 equals 10. So some sort of number that's added to 3 must give us 10. So just by looking at this quick and easy example, we know that 7 plus 3 equals 10, and therefore x must be 7. So the first method in solving equations is by using systematic trial. This is also called trial and error or guess and check. So by looking at this equation over here, we know that 2 times a number plus 3 gives us 11. This could also be read as 3 added to twice a number or double a number will give us 11. So similar to what we've done with the expressions by substituting a number in for n, we're going to be doing the same thing here, only this time it must equal to 11 because we are solving algebraic equations. So let's use guess and check by choosing any value that we want to represent n. So let's start with 1. Let n equal 1. Well, if we do that, we will have 2 times 1 plus 3. Let's see if that gives us 11. Well, 2 times 1 is 2, plus 3 is 5. That does not give us 11. Let's set n as being 2. So 2 times 2 plus 3. Does that give us 11? Well, 2 times 2 is 4, plus 3 is 7. Nope, that does not give us 11. Let's let n equal 3. So, 2 times 3 plus 3. Does that give us 11? Well, 2 times 3 is 6, plus 3 is 9. So no, that does not equal 11. Let's try another one. Let n equal 4. So 2 times 4 plus 3, does that equal 11? Well, 2 times 4 is 8 plus 3 equals 11. Yes, it does equal 11. Therefore, we know that n must be 4 in this equation. The second method of solving an equation is to solve by inspection. So if we look at the equation right here, in order to solve this equation by inspection, you need to ask yourself, what number subtracted by 20 can give me 5? Well, by inspecting this equation, we already know that 20 minus 15 will give us 5. Therefore, n must be 15 in this case. So some equations are a little bit more difficult to solve by inspection. So if we look at the one over here, we simply can't determine what n is just by looking at this. We have to do some more work. What we do know, though, is that 10 plus 3 gives us 13. So since I wrote 10 instead of the 2n, right here, we know that 2n must be 10. Now we need to ask ourselves, well, 2 times what number gives us 10? So just by simple multiplication, we know that 2 times 5 gives us 10. Now, we need to check to see if this 5 over here makes this equation true if we substitute the 5 instead of the n. So if we rewrite our equation, 2n plus 3 equals 13. Now, if we substitute the 5 for the n, so 2 times 5 plus 3 equals 13, and we solve, so 2 times 5 is 10, plus 3 equals 13, we can see that in fact the 5 over here substituted for the n in here makes this equation true. So lastly, we need to write n equals 5. So the third method of solving algebraic equations is by using something called a tile method. So we can use tiles to represent an expression. One yellow tile, for example, can represent a +1. And this is what we call a unit tile. But we can also use tiles to represent our variables. So this tile, for example, would represent x. And this is what we call our variable tile. Before we get started on an example, this tile method should look really familiar to you from your integers unit. Alright, so how can we begin to solve the equation 2 plus x equals 7 using this tile method? Well, in order to solve this, we're going to have a left side and a right side. So on the left side here, we're going to put tiles to represent our 2 plus x, things that are on the left side of the equal sign. So the way we can do this is using our legend above, we will put 2 tiles to represent our 2, and we will put an x tile to represent our x. Now, on the right side over here, we need to put tiles to represent our 7. So, how can we represent our 7? Well, we will put 7 tiles. So, 1, 2, 3, 4, 5, 6, 7. So now what we want to do is we want to have this x tile, or this x tile right here, on its own. This is called isolating the variable. Now, what we do to one side, we must do to the other. So in order to isolate this x variable over here, we must remove 2 tiles from each side of the equation. So now, if this tile over here represents x, and these individual tiles over here represent 1, what we're left with is x equals 5. And you can see that over here, because this is an x, and these are 1s. And in fact, x equals 1, 2, 3, 4, 5. So now we need to verify that x in fact equals to 5. Well, we can do one of two things. The first thing we can do is substitute 5 for x in our equation. So 2 plus 5 equals 7. So the first method showed us that x is in fact 5. The second method is in fact verifying that left side equals right side. So if we know that x equals 5, let's draw 5 boxes. 1, 2, 3, 4, 5. Plus our original 2 from up here. 1, 2. And now let's move on to the right side, where we had our original 1, 2, 3, 4, 5, 6, 7 boxes. 1, 2, 3, 4, 5, 6, 7. And as we can see, 7 on the left equals to 7 on the right. And the second method of verifying that 7 on the left equals to 7 on the right again proves that x equals to 5. So your ticket in the door for tomorrow is to solve the following equations. For the first one, you're going to be using the inspection method. The second one will be the systematic trial, so the guess and check. The third will be using the tile method. And the fourth will be solving with any method that you choose, either one of these three methods that we've discussed. Please record these into your math journals and show all your work. So whether it's drawing a table or drawing pictures to represent the steps you took. And for the fourth question, please describe the method of your choice. So I'll see you tomorrow, and good luck.